The planets, rocky worlds. Mercury, the shrinking planet. The science, thermal contraction. Mercury has a massive iron core that makes up about 85% of its radius, compared to Earth's 50%. As this core has slowly cooled over billions of years, it has solidified and lost volume. Because the planet's outer crust is cool and brittle, it cannot simply shrink smoothly like a deflating balloon. Instead, it buckles and fractures. The result, the crust breaks and thrusts one section over another, creating lob-bait scarps, massive cliffs that can be hundreds of miles long and over a mile high. Venus, the backward planet. The science, retrograde rotation. Venus spins clockwise, retrograde, while most planets spin counterclockwise. Scientists have two main theories for this. Giant impact. A massive collision with a protoplanet in the early solar system knocked Venus off its axis or spun it backward. Atmospheric tides. Venus has a crushing atmosphere, 90x Earth's pressure. The sun's gravity pulls on this thick atmosphere, creating thermal tides. The friction from these tides, acting over billions of years, may have slowed the planet's rotation to a halt and eventually reversed it. Mars, the blue sunset. The science, scattering on Earth. Our atmosphere scatters blue light, Rayleigh scattering, making the sky blue and sunsets red. On Mars, the atmosphere is filled with fine, micron-sized iron oxide, rust dust. The result, these dust particles are the exact size needed to permit red light to scatter widely while projecting blue light forward in a concentrated beam. When you look toward the setting sun on Mars, you're seeing this forward-scattered blue light punching through the haze. The gas giants, the kings of the system. Jupiter, the failed star. The science, nuclear fusion limit. Jupiter is composed of hydrogen and helium, just like a star. However, stars generate energy through nuclear fusion, which requires immense core pressure. Jupiter is massive, but it is still far too light to ignite this process. The threshold to become a brown dwarf, a substellar object, Jupiter would need to be 13 times more massive. To become a true star, like our Sun, it would need to be 80 times more massive. The Great Red Spot. This is a high-pressure anticyclone. It is stable because it is trapped between two opposing jet streams, bands of wind, that act like conveyor belts, keeping the storm spinning in place.